Hi folks, welcome to A Plus Calculus. My name is Vrinda and we are doing the series of DESMOS is God. Okay, and this is the third part of the series, and in this part we are going to see how we can do questions of finding out x and y intercepts on DESMOS. Okay, so the first one, I have taken three questions. First question is of a linear function, second one is exponential function, third one is also exponential function. Let's see the first one. The first one says that the function f is defined by f of x is equal to 7x minus 84. What is the x-intercept of the graph of y is equal to fx in the xy plane? So the function is f of x equals 7x minus 84. And what is the x-intercept of the graph? Now I will also be solving each and every question manually, and then we will check the answer on DESMOS, because as I always say, although you have DESMOS with you, you should know each and every question, how to solve it manually. So you have to find out the x-intercept. Now remember, if you have to find out the x-intercept, then you put y is equal to 0 in the equation, and if you have to find out the y-intercept, then you put x is equal to 0 in the equation. Now in this case we have to find out the x-intercept, so we put y is equal to 0. Now this is function notation, we write it in the equation notation, so y is equal to 7x minus 84. We put y is equal to 0, so 0 is equal to 7x minus 84. So 84 is equal to 7x, and that means x is equal to 12. So the x-intercept will be 12, 0. So option D is correct. Now this took us a couple of seconds, I think 30 seconds or so, and this also has the risk of making some calculation error. So if a question can be done on DESMOS, we will prefer DESMOS. Now what you have to do is, when you have to find out the x-intercept, just plot this equation on DESMOS, and we will see that at which point the graph of this equation will touch the x-axis. When you have to find out the x-intercept, you will see that at which point the graph will touch the x-axis. So alright, let's go to DESMOS. So we have y is equal to 7x minus 84, and zoom it out. Here is the graph, and it is touching the x-axis at this point, which is 12, 0. Now with DESMOS it will take you just less than 10 seconds, but you should know both the methods. Moving on to example number 2. Example number 2 is an exponential function. So we have the function f is defined by this. What is the y-intercept of the graph of f of x in the xy plane? Now in this case we have to find out the y-intercept. Let's write this function in the equation notation. So we have y is equal to negative 8 times 2 raised to x plus 22. First we will solve it manually and then on DESMOS. Now in this question I have seen a lot of students make a mistake of comparing it with a linear function. So you know that the linear function is given by y is equal to mx plus b, and in case of linear function, this b is the y-intercept. So some students confuse the exponential function with the linear function, and they select 22, which is the constant term, as the y-intercept. And the test creators, they know that you are going to confuse it with the linear function, and that's why they have given this option 0, 22. You will see that and you will select it and you will lose your points. Okay. See, even in linear functions, the logic is not that the constant term will be the y-intercept. The logic is that you put x is equal to 0 in the equation, so you get y is equal to m times 0 plus b, and that's why you get the b as your y-intercept. But in exponential functions, when you put x is equal to 0, so you'll follow the same steps. Put x is equal to 0 in the exponential function as well. In the exponential function, you will not get 22 as the y-intercept when you put x is equal to 0. So you have y is equal to negative 8 times 2 raised to x plus 22. We will put x is equal to 0. So x is equal to 0 to find out the y-intercept. So y is equal to negative 8 times 2 raised to 0 plus 22. So 2 raised to 0 becomes 1, and you are left with negative 8 plus 22. And 22 minus 8 is how much? So it is going to be 14. Okay. Now that means that your y-intercept is going to be 0, 14. And not 0, 22. So in the case of exponential functions, you can simply just add the coefficient and the constant term, because this term will always become 1 when you put x is equal to 0. Now let's do it on DESMOS. We have y is equal to negative 8 times 2 raised to x plus 22. And when you have to find out the y-intercept, you will see that at which point the graph is touching the y-axis, and it is this point, 0, 14. So our answer was correct. Again, with DESMOS, it will just take you a few seconds. Okay. Let's move to the third example. Okay, third example is again an exponential function. If the given function g is graphed in the xy plane where y is equal to gx, what is the y-intercept of the graph? Okay, let's do this. So you have y is equal to 11 times 1 over 12 raised to x. You have to find out the y-intercept, so you put x is equal to 0. This is 0. So 1 over 12 raised to 0 becomes 1, and you get y is equal to 11. So the y-intercept will be 0, 11. I think in this case, in this example, doing manually would be faster than going to DESMOS, typing the equation, typing the parentheses. And yeah, I think in this question, doing it manually would be faster. But let's also see this on DESMOS. So we have y is equal to 11 times 1 over 2 raised to x. Raised to x, and the y-intercept is 0, 11. Okay, so that was it for this lecture, and I'll see you in the next video. And if you want to try out my tutoring classes, I also provide one-on-one tutoring. The details of that are mentioned in the description box. You can book your 2 free demo classes, one-on-one free demo classes. I offer the first 2 classes for free. You can check out my tutoring style. If it meets your expectations, then go ahead, and I'll just stop here. Alright, I'll see you in the next lecture.